9.2 is called the elimination method. And you learned substitution yesterday, and today you're going to learn eliminating. So you're going to eliminate a letter, or a variable, sorry. So you can either eliminate the x's or the y's, and you want the y's to have the same number in front of it, but opposites of each other. So, well, this one already has a -3. So I'm going to put a 3 in front of the other one. So I'm going to recopy the first one down. And I'm going to multiply this whole second equation by 3, which gives us 6x plus 3y equals 21. And then you draw a gigantic line underneath it, and you should always add if these two right here are opposites of each other and the same number. You don't have to eliminate the y's. I could have eliminated the x's also. Just as long as the numbers in front of them are the same number but opposites of each other. All I'm going to do now is add up the columns. So 5x plus 6x is 11x. The -3y and a positive 3y cancel each other out. 23 and 21 makes 44. Divide both sides by 11, and x is equal to 4. So x is equal to 4, but you also have to find the y value. You can just plug x into any one of these equations. You can put it up into this one or back into this original problem. I'm just going to put it back up into this one. So if x is 4, 5 times 4 right here, 5 times 4 is 20, minus 3y equals 23, -3y equals, subtract 20, I get 3, divide both sides by -3, y equals a -1. What this means is that this answer needs to work in both equations. So you could easily check it on the test if you really wanted to. Okay, let's do another one. It's called the elimination method. Again, here's number 2. You can either eliminate the a's or you can eliminate the b's. It doesn't matter which one you eliminate, as long as you get the same number in front but opposites. I did the y's on the first problem. I'm gonna do the a's in this one just to change it up. So I have to think of a number bigger than the 2 and bigger than the 3 that 2 and 3 can go both into. And I'm going to think of the number 6. So I'm going to multiply this equation by 3, which makes 6a plus 24b equals a -24. So I multiplied the first equation by 3. I'm going to multiply the second equation by a -2. And you'll see why I multiplied by a -2. So a -2 times 3a is a -6a. A -2 times a -5 makes a positive 10b, and 22 times a -2 is a -44. And then draw your line, and you should be adding every time because you should have picked numbers that were opposites of each other, and these two are opposites of each other, which will cancel each other out. 24b and 10b gives us 34b equals a -68. In order to get b alone, I divide both sides by 34. So b is equal to a -2. You're not done though. I have to go back up into any one of the equations. I'm just going to go up into the 2a plus the 8b equals a -8. I'm going to replace my b with a -2. So it's 2a. 8 times a -2 is a -16 equals a -8. 2a equals, add 16 to both sides, I get 8. So a equals 4. The book will write it as an ordered pair alphabetically. The 8 comes first, so it's 4, -2 should be the answer. Okay, before I move on to the last problem, I just want to talk about one other thing that's going to happen in this lesson on 9.2. This is 2 other scenarios that could happen. You could have one like this, 2a plus 3b equals 4, a negative 2a minus 3b equals 3, you might have a problem that looks like this. Well, these are already opposites of each other, and it makes 0. These are already opposites of each other, the b's, and that makes 0. So 0 equals 7 when you add up all the columns. But when your a's and your b's cancel out, and you get a false statement like 0 does not equal 7, this is a no solution. So you might have some of these today where it's a no solution or a 0 with a line through it. Or you could have another scenario where it's 2a plus 3b equals 0 and a negative 2a minus 3b equals 0. And when you draw your line, these two, again, the a's cancel out and the b's cancel out, so you're going to have a 0 on the left side, and you also are going to have a 0 on the right hand side. If you get a true statement like 0 equals 0 or 4 equals 4 or 7 equals 7, this is going to be infinite or many solutions. I think the book says infinite. If you want to say many, you can say many infinite solutions. So those are the 3 types of scenarios of problems. You're either going to get an answer like 4, negative 1, or an answer like 4, negative 2, or whatever the answer is. Or you could have a no solution. That's if your variables cancel out and you get a false statement. Or you can have a many solutions if your a's and your b's cancel out and it's a true statement. Okay, last problem of the day. A story problem again. The price of admission to a carnival is $2 for students and $4 for adults. If 700 tickets were sold and they made $1,770, find the number of students and adult tickets. So I'm going to say A stands for adults, and I'm going to use S for students. Just like these problems, you're going to have 2 variables and you're going to have 2 equations. So we need to come up with 2 variables and 2 equations. So here we go. We know that I'm going to use A for adults and S for students. And I know that there were 700 tickets sold. We just don't know how many of each. So one equation is going to be how many adult tickets and how many student tickets, but both of them add up together to make 700 tickets. So A plus S is equal to 700. And then we know that they made and sold $1,770 worth of tickets. But in front of the adults, you are going to put a 4 because adults tickets are $4 and student tickets are $2. So, and only difference is they don't give you the equation and you have to set up the equations. And now that you have your 2 unknowns and your 2 equations, I am going to solve this problem just like I did those other problems by the elimination method. So I'm going to copy down the first ones, or the second one, sorry. I can either eliminate the A or the S. It's up to you, whichever one you want to eliminate. I'm going to eliminate the A. So if I eliminate the A, I have to multiply the first equation by a -4 so that these 2 are opposites of each other. So underneath it, I'm going to have a -4A, a -4S equals a -4 times 700 is a -2800. And then draw your line and put a plus sign. I guarantee you, you're going to have at least one problem on the ACT using the elimination method. It's the quickest method. The A's cancel out. 2S take away 4S is a -2S equals a positive 7. Let me do this quick. A positive 1,770 minus 2,800 is a -1,030. Divide both sides by a -2. S is going to equal 515. What does that mean? 515 tickets. And if there was 515 student tickets and there were 700 altogether, I'm just going to go back up in here. A plus S equals 700. It was one of my original problems. And I know students was 515. A plus 515 equals 700. So the adults is going to be 185 tickets. And your assignment for today, if you don't want to look at the sheet, is this. For 9.2 in the book, you are doing problems 1 through 6, 13, 14, 17, and 21. So you have 10 problems by using the elimination method. And that's all the notes for today.